For nearly 3 decades, one number has sat at the very foundation of modern cosmology, a figure so widely accepted that textbooks, museum placards, and science documentaries all repeat it as settled fact, taught to schoolchildren and cited in scientific papers alike as though it were beyond question. 13.8 billion years. That's how old scientists have said the universe is, ever, since precision measurements locked the figure into place. But right now, deep inside the data pouring back from the James Webb Space Telescope, that number is under more pressure than it has ever faced before, and a growing number of astronomers are quietly admitting that something about our timeline of the cosmos simply doesn't add up. Like and subscribe if you want to follow this story all the way to the edge of what we actually know about time itself, because what Webb has found is stranger than most people realize. To understand why this matters, you first have to understand where that 13.8 billion year figure actually came from. Scientists calculate the age of the universe primarily by measuring how fast space itself is expanding, a number known as the Hubble constant. Back in the 1990s, before better instruments existed, estimates for the universe's age ranged wildly, anywhere from 7 billion years on the low end to 20 billion years on the high end. It wasn't until measurements improved, particularly through observations of the cosmic microwave background, the faint afterglow of the Big Bang itself, that scientists converged on 13.8 billion years as the accepted consensus. For years, that number held firm, treated as one of the most secure figures in all of physics. Then, in December of 2021, NASA launched the James Webb Space Telescope, a machine built specifically to look further back in time than any instrument before it, capturing infrared light that has been stretched and reddened by billions of years of cosmic expansion before ever reaching our detectors. Webb's mirror alone is nearly 3 times the diameter of Hubble's, giving it dramatically greater resolution and the ability to detect objects roughly 9 times fainter than anything Hubble could ever hope to see. Because it observes primarily in infrared wavelengths, Webb can also peer straight through thick clouds of cosmic dust that would completely block visible light, revealing structures and galaxies that had simply remained hidden from every telescope that came before it. Almost immediately after Webb began its science operations, it started finding things that shouldn't have existed, according to everything astronomers thought they understood about how galaxies form and grow. If you're just discovering this channel, make sure you like and subscribe, because what Webb found next completely upended decades of assumptions about the early universe. Astronomers began calling them the impossible early galaxies. These were galaxies observed at a point when the universe, according to the accepted timeline, was only 500 to 800 million years old, barely a cosmic infant by any measure. And yet, these galaxies didn't look young at all. They appeared unusually bright, unusually massive, and in some cases, chemically developed in ways that should have required multiple generations of stars, living, dying, and seeding the cosmos with heavier elements, a process that standard models say simply cannot happen that quickly. In one particularly striking case, spectroscopic measurements of the extremely distant galaxy MOAM-Z14 revealed an overabundance of elements like nitrogen and carbon, chemical signatures that, under conventional stellar evolution, would normally require several complete generations of stars forming and exploding before that much of those elements could exist. Finding that level of chemical enrichment in a galaxy dating back to when the universe was supposedly less than 300 million years old left many researchers struggling to explain how nature could have moved that quickly. Some of these galaxies displayed organized shapes, defined structures like disks and central bulges, the kind of features astronomers associate with galaxies that have had a long, calm history of star formation, not ones that supposedly formed in a fraction of the time available. One of the clearest examples of this puzzle is a galaxy called JADES-GS-Z14-0, observed at a redshift of about 14.3, corresponding to a time when the universe was less than 300 million years old. Redshift, for anyone unfamiliar with the term, is how astronomers measure cosmic distance and time. As the universe expands, light from distant galaxies gets stretched toward longer, redder wavelengths, and the more that light has been stretched, the further back in time astronomers are actually looking. A higher redshift number means an object existed earlier in cosmic history, closer to the Big Bang itself. Webb has now pushed that redshift record even further, with a 2026 paper reporting a spectroscopic redshift of 14.44 for a galaxy called MOAM-Z14, making it, at least for now, the most distant, and therefore the earliest, galaxy ever confirmed. What makes these discoveries so unsettling isn't simply that Webb is seeing further back than ever before. That was always the plan. It's that what Webb is finding at these extreme distances doesn't match what the standard model of cosmology predicted it would find. Webb has also spotted something researchers have nicknamed little green galaxies, compact starburst galaxies packed with intense star formation, existing roughly 1 billion years after the Big Bang, which may have been responsible for flooding the early universe with the ultraviolet light needed to reionize hydrogen atoms scattered throughout space. In some cases, Webb has even spotted galaxies that should have been completely obscured by clouds of neutral hydrogen at that point in cosmic history, yet there they are, visible, implying that the reionization process, the transformation of the early universe from a dark, opaque fog into the transparent, star-filled cosmos we see today, may have started far earlier than anyone predicted, or that something unexpectedly powerful was producing radiation nobody accounted for in the models. This is the part where the story genuinely splits scientists into different camps, and the disagreement runs deeper than a simple debate over a single number. The mainstream position, held by the overwhelming majority of cosmologists, is that these findings don't actually disprove the 13.8 billion year figure outright. Instead, they argue that galaxies in the early universe simply formed and evolved faster and more efficiently than existing models predicted, meaning the timeline itself might still be correct, but our understanding of how quickly matter can organize itself into massive, structured galaxies needs a serious overhaul. Under this view, Webb hasn't broken the age of the universe, it's broken our theories of galaxy formation, forcing scientists back to the drawing board to explain how nature managed to build such complex structures so quickly after everything began. But a smaller, increasingly vocal group of researchers has proposed something far more radical. Rather than assuming galaxy formation happened impossibly fast, what if the underlying timeline itself is wrong? One prominent alternative model published by researchers examining exactly this problem proposes that the universe isn't 13.8 billion years old at all, but roughly 26.7 billion years old, nearly twice the currently accepted figure. This model attempts to resolve the impossible early galaxy problem directly, by essentially giving those ancient-looking galaxies far more time to develop the mass, structure, and chemical complexity Webb is observing without requiring any dramatic rewrite of how galaxy formation actually works. Supporters of this longer timeline point to a pattern that keeps repeating in Webb's data. Smaller galaxies appearing more massive than larger ones, a relationship that runs completely opposite to what standard cosmological models expect. In ordinary galaxy formation theory, bigger, more evolved galaxies should generally correlate with greater mass, built up gradually over cosmic time. Finding the reverse pattern again and again at extreme distances is exactly the kind of persistent anomaly that makes some researchers suspect the problem isn't with the galaxies themselves, but with the assumed age of the universe they're being measured against. Perhaps most striking of all is a galaxy discovered by Webb, nicknamed Zulong, an enormous, fully formed spiral galaxy that researchers have described as looking almost like a cosmic twin of our own Milky Way. Despite existing at a point in cosmic history when structures that large and that organized simply weren't supposed to have had time to assemble yet. There's an additional deeper tension running underneath all of this too, something cosmologists call the Hubble tension. Even before Webb launched, different methods of measuring the universe's expansion rate had already started producing conflicting results. Measurements based on the early universe, using the cosmic microwave background, produce one value for how fast the universe is expanding. Measurements based on nearby stars and galaxies in the more recent local universe produce a noticeably different value. These two numbers should agree if our fundamental model of cosmology is complete and correct, and yet they stubbornly refuse to match, no matter how much scientists refine their instruments and methods. Some astronomers have spent entire careers trying to track down a hidden measurement error that could explain the gap away, checking calibration methods, distance ladders, and statistical assumptions again and again, and yet the discrepancy has only grown more stubborn with each new generation of instruments. Webb has continued to affirm that this discrepancy is real, not simply a measurement error waiting to be fixed, adding yet another layer of uncertainty to a field that was, until recently, considered one of the most settled areas in modern physics. Some researchers have proposed alternative explanations that go even further outside the mainstream, including models suggesting that light itself behaves differently than assumed over vast cosmic distances, a concept sometimes referred to as tired light theory. However, this particular idea runs into serious problems when checked against other independent lines of evidence, including the redshift patterns seen in distant supernova explosions and the remarkably uniform temperature of the cosmic microwave background across the entire sky, both of which are difficult to explain under a tired light framework without introducing entirely new physics that hasn't been observed anywhere else. What makes this entire debate so fascinating and honestly so unsettling for a field built on precision is how quickly the anomalies keep accumulating. It isn't just one strange galaxy or one unusual measurement that could easily be dismissed as an outlier or an instrument error. It's dozens of independent observations, gathered across multiple survey programs, using multiple instruments aboard the same telescope, all pointing toward the same uncomfortable pattern: structures in the early universe that appear too developed, too massive, and too organized for the amount of time standard cosmology says they had to form. Every year, Webb continues operating. The list of anomalies grows a little longer, and the gap between quiet certainty and open scientific doubt continues to widen. It's important to be clear about where the science actually stands right now, rather than where the more dramatic headlines might suggest it stands. Mainstream cosmology still firmly holds on to the 13.8 billion year figure, and the vast majority of working astronomers believe the impossible early galaxy problem will ultimately be solved through better models of star formation efficiency, rather than a wholesale rewrite of the universe's age. Some analyses of Webb's data have even pushed back directly against the more sensational framing circulating online, pointing out that properties like brightness, chemical richness, or an organized shape don't automatically prove a galaxy spent billions of years quietly evolving before the universe was old enough to allow it. A galaxy can look mature without actually being ancient, and separating genuine evidence of extended cosmic age from simply unexpected efficiency remains one of the most difficult challenges in this entire field right now. Still, the fact that this conversation is even happening at this level, inside peer-reviewed journals, at major astronomy conferences, among scientists who have spent entire careers treating 13.8 billion years as bedrock truth, tells you something important about where we actually stand. It's worth remembering that this isn't the first time our understanding of the universe's age has shifted dramatically in the face of new evidence. Before precision instruments existed, estimates swung wildly across a range of more than a decade of billions of years, and it took generations of careful, incremental measurement to settle on the figure most of us grew up learning as fact. If that number moves again now, it won't be the first time cosmology has had to humble itself in front of better data, and it likely won't be the last. Webb wasn't built to overturn the age of the universe. It was built to look further back into cosmic history than any instrument before it, and in doing exactly that, it has uncovered a set of galaxies so unexpectedly developed that they forced serious, credentialed scientists to openly question one of the most fundamental numbers in all of physics. Whether the final answer turns out to be a revised model of galaxy formation, a genuinely older universe stretching back 26 billion years or more, or some entirely new piece of physics nobody has proposed yet, one thing is already clear. The confident, settled certainty that once surrounded that 13.8 billion year figure has quietly cracked. And as Webb continues staring deeper into the past with every passing month, gathering more data, finding more of these impossibly early, impossibly massive galaxies, the pressure on that number is only going to keep building. If this journey into the strange edges of cosmology fascinated you, like and subscribe, because as James Webb keeps peering further back toward the beginning of everything, the true age of the universe may turn out to be one of the biggest scientific surprises of our lifetime, one that could reshape how we understand the very origin of space, time, and everything within it.